Hello, everyone. Good afternoon to you all, and happy New Year. In this New Year, this our first class. All what we have been doing, before in last year was design of a slab. All right, so we are done with slab design. We are moving to beam design. So, but before we start designing the beam, we like to first of all explain to all the civil engineers how loadings are transferred from one structural member to the other. All right, but what we are going to be doing subsequently is the first floor beam design. So the first floor beam designs are going to be analyzed, and we are going to show to everyone how the loadings or the loads are transferred from the block wall, the partition load, then the slab, then to the beam. So first thing first, let's take for example, we have a structure like this. This a story building once with one suspended floor. All right. So we have the roof, we have the roof beam, then we have this one. I call this one slab so that we differentiate it. I call this one slab. All right. I call this one the slab. I recall that the thickness of our slab is 150 mm. All right. Then the beam. The thickness of our beam, the height of our beam is the from the beam you add the slab to it makes it 450. All right. So when we are now designing, it is our design and analysis that will now tell us if the beam, if 450 is not adequate for this beam, if we are to increase this from 450 to 650 or to 600 or from 600 to 750. So, but for now we are using 450, and I want you to know that the height of the beam is, you are adding the thickness of the beam of the slab to the beam to make it, all right, 450. So how are the loadings transferred from each member to the beam? No, remember we are talking about the first floor beam. Now we have roof. The roof load is going to be transferred to the roof beam. All right. So the roof beam will take care of the roof load. After transferring the load from the roof to the roof beam, then the roof beam transferred to the columns. All right. Now, if you are talking about the first floor beam now, we are going to be calculating the loads on the wall, then of the slab. We add this load and this load and this load together. So that will not be the load that the beam will transmit to the column, then from the column to the foundation. All right. Now, how do you now calculate the wall load? Now you have been given the height of the wall to be 3 meters. All right. No, remember we'll be making use of 3.3 because of the headroom. So the height of our room is 3.3. All right, 3.3. Okay. So how are you now going to calculate the wall load, the slab load, and the beam unload? Now we said, assuming the clear span between column and column is 4.2, this is the first stage. This is the first thing to do because you already know the height, all right? You know the width, so we'll not have to calculate for the wall load. From the BS code, wall load 225. That's 225 mm. The load is 3.47 kilonewton per meter square. All right. This is the load for this type of block wall. Okay. Now we are talking about the height 3.3. Okay. So if you want to get the wall load now, you say wall load wall load is equals to 3.47 multiplied by the height 3.3 multiplied by the factored load. It's a dead load 1.4. All right. When you compute that, please, my calculator. When you compute that, you now have your wall load to be 3.47 multiplied by 3.3 multiplied by 1.4. All right, this one will now be equal to 16.03 kilonewton per meter. All right, that's our wall load. It means that this wall, the loadings on this wall to the beam is 16.03 kilonewton per meter. Now, recall that when you are now calculating the loads that will be transferred from the slab to the beam, all right, we have one of our this is a panel, all right. From what we have been designing all along, we have 4.225 here, then we have 4.1125 here, all right. This is a rectangular section. This is the LX, this is the LY, while this one is the LS. Let me represent it very well to make this other side be shorter. All right. Now it's like this. All right. Now this is a two-way spanning slab. Two-way spanning slab. The way the slab will distribute the load to the beam is like this at an angle of 45. At an angle of 45, then like this. All right. Don't mind my sketch. Like this. And let me draw it very well, please. All right. Let me draw it very well. This is 45 degrees. This is another 45 degrees. Then like this. All right. So this is the LY, while this is the LS. Okay. Now, assuming this is the LX, LY, how do you now transfer this load from this slab to this? Now, there's a formula for it. All right. For the longer span, for the long span load on beam. All right. We have the formula to be load is equals to 1/2 WLX multiplied by 1 minus 1/3K squared. What is our K here? Our K here is K is equals to LY over LS. That's the ratio of our LY over LX. Okay? Now, we will move to our design subsequently when we are doing it, but I just want to explain how the load from the slab is transferred to the beam. So, but for the shorter span, assuming this is beam here, this is another, now the load from the slab to the beam along the longer side of it, along the LY, the formula is this, where the W is the load from the slab, is the ultimate design load from the slab, while this one is the LS, shorter span. Then this one is K, as I said before, LY over LS. Okay. Now for this shorter span, the load will now be 1/3 is 1 over 3 WLX. Now, assuming this slab is here, the load that will be transferred from the slab to the beam is using this equation. Using this formula. From the logger span, the load that will be transferred from the beam, from the slab to the beam, is 1 over 2 WLX 1 minus 1 over 3K squared. Alright? This is how to get the load from the slab to the beam. Alright? So, then what about the beam own load? How do you now get the beam own load? We are saying here now from here to here is 4.2. Now, to calculate the beam load, beam load, we said that the beam is 450 by 225. So the section is this. All right, from here to here is 450, while from here to here is 225. Okay, now the beam load now will now be equal to 0.225 multiplied by 0.45 multiplied by the density of concrete, which is 24. All right, let me clean this. Okay, so when you compute that, you are going to have 0.225 multiplied by 0.45 multiplied by 24. This one will give me equals to 2.43. Remember that beam load is also a dead load multiplied by 1.4. This one will give me multiplied by 1.4. This equals to 3.40 kilonewton per meter. All right. Now, then we now have to beam finishes. Is also taken to be 1.2. All right, kilonewton. So when you add, you now have 4.6 kilonewton per meter. All right, so that is our beam own load. So when you now sum all this together, remember when you now, after solving for this, you add it to this, you add it to this to now be the load on the beam. All right, that is that for today. When next we come, we are going to take this to the design we will be working on so that it will be clearer. Thank you, and stay blessed. All right, in our next class, we'll be bringing our design so that we'll now put in our values for the load on the slab. Then we'll now add everything together to get the loadings on this on the beam, so that we can start our analysis and design. So for today, that's it. Stay blessed.